These bugs are so cute. In what class? It looks scary. Oh.
It's not bad. It's just
It looks like a lot of numbers.
yeah.
All right. Good morning, everyone. Happy Wednesday. We are going to get started today talking about one of my favorite things to talk about ever, which is using NumPy and introducing this new package called Pandas. Yay. Before we get started with lecture, again, for those of you who just walked in, please go on B Courses and download the file called titanicdata.csv, because we're going to be using that in lecture today, so I can show you guys and have you guys load in a data set of your own, which will be super helpful. Oh, cool. Announcements. As we know, final project proposals, please get those into us so we can give you feedback and we can make sure that, you know, your final project ideas are slay. Charlie, did you have?
Oh, yeah. Yeah, very few people have, or there's a solid amount of people who have not turned in their project proposals. That's fine and slay because Friday is the late due date, no penalty. Please, please, please reach out to me if you have extenuating circumstances or if you are having a lot of issues with it. We do not want you to struggle in silence. Oh God, there was one other thing. And if you are working in a group of 2, please make sure that you have added your group mate onto the submission. We do not have the time to go through and make sure and like manually add everyone's group mates. So just double check, please. I'll send out an announcement about this as well. I can see there's a few missing faces. I'm assuming because of midterms and also spring break is coming up. So thank God for that. Yeah. Over to you, my love.
Other things, homework 6 is due this Friday, but also you will have the grace period of the 3 weeks to get it done if you need to. We know that spring break is next week, so like we won't be holding our office hours, but again, literally as soon as spring break's over, feel free to come by, we'll help you out. And we also have office hours for the rest of this week for anyone who would need to come by. Homework 7 is going to be dropped today and it will be due after spring break. Either a week or 2 weeks after spring break. You guys have some time for that one. So try to get a head start on it. It's okay. If you can't though, make sure to take spring break as a break. Very important to do that.
Yeah, clock out if you can.
Clock out if you can. Cool. So let's do a little recap. So far, we have worked a lot with NumPy, which is technically right now our go-to Python package to kind of literally do almost anything that we've worked on in the past like couple weeks. We have array operations, we can do statistics, we can do a bunch of fun stuff. So super helpful package. So far we've been able to do things like we've explored some basic data structures, like we've looked at dictionaries, we've looked at lists, we've looked at tuples, so on and so forth. We've looked at conditionals, functions, loops, all this stuff. All of this stuff basically allows you to do the data processing part of it. Like you're able to take a bunch of numbers, do a bunch of things to them. So you're able to process data. What we need to figure out how to do is actually take in real world data and like make it usable. Unfortunately, data in the real world is very different from data that we are used to. Looking at in like a nice little CSV file. For example, looking at Astro Image CSV that I gave you guys, you didn't have to look inside that file because it was a very nice, clean data file. There was nothing in there that would like ruin your plots. But data in the real world, because it's coming from real-time sources, there's usually a shit ton of it, and it's always really, really messy. Because it's coming from real-time observations, there's always errors, there's always fluctuations, especially if you're taking it off like a certain instrument, like from a telescope or from like something like that. There's going to be errors, there's going to be missing data points. And also sometimes like when people are collecting data, they might not do it in like the most intuitive units or the most intuitive structures to you for you to use them. Unfortunately, sometimes they might just output like a bunch of numbers and you're like, I don't know what to do with this. But the important thing is we need to learn how to save all that data and start cleaning it and processing it so we can use it. Cool. This is an example of real world data. This is data I work with in my research. It looks very tiny on here, but I worked with data from the MIGHTY instrument that was on the ICON mission that I work with at SSL. This is a weird data set, but all you kind of need to know and see here is there's a lot of numbers and there's a lot of features. And I don't know what most of this means, but I have to use it. So my entire like challenge is figuring out how to parse through almost like, it's multidimensional data. So I have like 7,000 something rows, 33 something date times, and 84 altitudes. And I have every single one of these variables at all of those data points. So like it's a lot of values. And this is only one of like the 4 data sets I work with. People also tend to work with a lot more data than this. This is just an example. So we can see it's really messy. It's really difficult to understand, but we got to use it anyway because that's the data we got and we got to work with it. Oh, I was going to post this on Ed and I forgot. Let me do a quick Ed post. I want you guys to, oh, it's because I have the link open. You guys can type this into your browsers, but I feel like that's making you do a lot of work. So I'm going to post this on Ed. And what I want you guys to do is basically take a quick look at this data. And we're going to see some like, we're going to form some ideas of how data analysis and data exploration works. Neat. Cool. That has gone on Ed now, so everyone should be able to click that link. Sorry, I forgot to do that earlier. Okay, so basically, once you guys have a chance to open up this link, it's going to take you to a salary survey from this website called askamanager.com. And you can look at the little webpage and it'll show you a bunch of data about different people's jobs, their ages, industries, yada, yada, yada. There are 17 variables apparently from when I looked at it. And a lot of the variables, or at least a few of the variables are like freeform text entry. Basically what this data set is collecting is there's a little Google form on the original website. So people can kind of just fill that out to like contribute to a data set. So it's live, it's growing, and yeah. So let's open this up. Cool, so you can see, so this is a little Google form that they have you fill out. And I just want you guys to hit view all the responses in a sortable spreadsheet. So here is a data set. Here is a real-time live data set with a bunch of information. It's in the form of Google Sheets, which is basically the same thing as like a CSV file. So yeah, you see like a nice little table with a bunch of information about people's ages, their jobs, their salaries, and a bunch of other stuff. So what I'm going to ask you guys to do is I want you guys to look through this data set, just take like a minute or two and come up with, I said 3 ideas, just come up with an idea or 2 of how you can make this data more usable or more readable. If there's anything in there that you're like, this could be a cool thing to look into, but I can't really use these numbers in this state, or I can't use this information in this state, how could we do that? Cool. And if anyone has any ideas, just yell them out. Yeah. So like filtering by. Yeah. Yeah. So that's perfect. Cool. So that's a really good point. So if you see like the annual salary, for example, it's not in any order. It's not an ascending order. It's not a descending order. You kind of jump around and guesstimate. So like the suggestion said, you could always have them organized into certain categories of like who is spending how much. You can bin them into certain categories like that. Cool. Do we have any other ideas of how we can make this data more usable and useful to us? One of my first observations when I looked at this data set, you see this column, it says, please indicate well, I guess you can't see the whole thing, but it's basically asking you to indicate what currency you make your money in. So all these numbers are apparently not in US dollars or not in the same currency. Something super helpful to us could be to convert all of your currencies to the same standardized system. So those are like little things, some examples of like what you can do to clean up your data. This, I would say, is a relatively clean data set because you can take a look at it and visually understand what's where. Because it's like a cute little table and they've given you all the labels and the categories and this and that. That's not what you're going to get out of like real life instruments most of the time. It works like this because it's a nice little Google form. But yeah, you can take a look at a bunch of information from a bunch of people, which is really cool. And yeah, so an example that one of the first things I noticed was the currency. So things like that would make our data more useful, more readable, more helpful to us. And then exercise 2, come up with like 1 or 2 questions that this data could help you answer. Just looking at the information given to you on the spreadsheet, what are some things that are like, ooh, I could use this data to figure out these things about these individuals that have filled out this form. Could be anything super simple. It doesn't need to be crazy. It doesn't need to be super complicated. Just come up with some questions that you're like, oh, fun. You can also just shout them out once you come up with your questions. No questions? Any questions? Yeah. Yeah, that's a really good one. So correlating your age or like how many years you've been in the workforce to how much you're making. That was yours. Okay, cool. Valid. Yep.
How much you make versus which state you live in?
That's a really good one. Looking at how much you make versus where you live / where you work. Because different places have different minimum wages. So you could be making relatively more somewhere when you're living with a lower cost of living. Anything else? Anything else that's fun? Oh, unique.
Same job, different countries, and how much they make.
That's also really good. Looking at relatively how much people are being paid in different countries. Yep.
How much you make and what industry you work in.
That's a really good one. So you can see how there's a bunch of the industries are kind of given categories. So you see like nonprofit, law, government. So looking at how much different people make within those industries, what the average is per each industry. That's a really good one. So looking at the number of years like you've been out of, I think there's a category of like how many years of professional experience you have. So looking at how much you make based on that. Okay, great. So these are all really, really good ideas. You were able to just take a look at this data set for like a minute or two and come up with so many different questions that you can answer, which is really exciting. Ooh, my slides. Cool. What you guys just did in the most like basic fundamental way is the process of exploratory data analysis. This is basically a bunch of fancy words saying, hey, I can take some data, look at it, figure out what some good questions to answer with it are, and process my data according to this, what I want to do with it to make it useful and make it usable. And that's what that's like the core idea of data analysis. Like that's kind of all you're doing. You're given a bunch of numbers and you're asked to make conclusions with it. So that's what we're doing. That's fun. It's called EDA. If you take this really cool class called Data 100, which is a SLAE class, they spend a lot of weeks on this. But that's the whole idea of it. So what we're going to do now is introduce this new package called Pandas. Right now, we don't have the tools to actually, if we have the data as a CSV file, we looked at numpy.loadtxt very, very briefly last week, or last class actually, but we don't really have the tools to like parse through large data sets, load in large data sets. So we're going to learn how to do that now. Pandas is basically this really, really nice data analysis library that helps make this process of EDA super fast, super convenient, super intuitive. And thankfully, it's really, really well integrated in with NumPy. So you can use a lot of functionalities from NumPy in your Pandas work and vice versa. The really big difference though, NumPy is very array-based. You have like a set of numbers, a 2D array, you're able to do operations on that. Pandas though, it is designed for tabular data. So it's designed for these data tables of a bunch of different numbers that you want to work with. Cool. So now we're going to get into some of like the basic data structures in Pandas. There are three. The first one is a PD.series, Pandas series. It's basically like a NumPy array, but it's like a Pandas equivalent of it. So think of it, you can think of it as if you have a data table, if you want to select like a column of data, that is a Pandas series because it's just a bunch of numbers. It's just a list of numbers. Very similar to a NumPy array. The second one, which is Holy Grail, that's what we're going to work with all the time, is a Pandas data frame. A data frame is basically a table. You have a bunch of rows, you have a bunch of columns, and you can store tabular data, which is super, super helpful. And then PD.index is something we'll get more familiar with, but it's basically, if you have a bunch of rows and columns, it's the way Pandas knows what your data is and what your row and column labels are. So each like row and column will have a bunch of indexes. So the same way that you can index positions in a list, you can index rows and columns in a data frame. And all of this will become a lot clearer when we do our little demo. Yay. Cool. So if everyone can open up an empty Jupyter notebook, we're going to go through some basic Pandas fundamentals together. So first step always, first step that I miss a lot of the time, and then I'm like, oh, my code's broken, is importing your packages. For today, we're going to import, oh, I should probably zoom, huh? Is this visible to people in the back or we need more? Okay. So we're going to import NumPy as NP. And our new package is importing Pandas as PD. PD is the most common alias that you use for Pandas. That's kind of just the standard. Lovely. I'm also going to have you guys import something called, you don't need to know what this is. It's basically a package that contains a bunch of data that you can use, just a bunch of statistics data. And I'm just going to have you import that. So we have stats models.api as SM. It basically just contains a bunch of different data that you can just steal from them, which is really nice. Yay. All right. Load, please. Okay, well, hopefully the cell runs for more people than it's running for me. But as that cell's running, what we're gonna do now is learn how to create a data frame. There are 3 ways that you can create a data frame. Way number 1 is you could just literally make it from scratch using a bunch of NumPy arrays. Number 2 is you can create it from scratch using dictionaries. So those are the 2 ways you can create it from scratch. Number 3 is the most common method. It's what you're probably going to use. We're not usually making data frames like entirely from scratch. You're usually converting existing data into your data frames. So that's what the third way to do is like from an existing file or from an existing source of data, how do I load it into Pandas? Those are your 3 kind of ways. And we're going to do an example of each one. So our first way, creating a data frame. Yay. So we're going to do one from scratch using NumPy arrays. One. Okay. So we're going to create a data frame. So I'm going to call it df1 because data frame, it's my first data frame that I'm making. And the way you initialize a data frame is you do pd.dataframe And it's also really nitpicky about that like data frame that F is capitalized and the D is capitalized. So be a little careful. I've made that mistake a million times. Cool. So the way you're going to do it is you remember how in NumPy you can create an array. So we're going to create a NumPy array and store a bunch of data in like certain rows and columns. So I'm going to initialize a NumPy array that we do using np.array. You put in the little guys. Okay. I'm just going to create like a super basic, like it's going to be 1, 2, 3. Ooh. It's going to be 4, 5, 6 because I'm kind of boring like that today. 7, 8, 9. Cool. So let's say I want those to be my data in my data frame. I'm really hoping that I've syntaxed this correctly. I actually most definitely have not syntaxed this correctly. These all go in one bigger set of square brackets. So you can see like I have my one big set of square brackets denoting the array, and then each little, you got little sub lists almost going of what you want in each column of your data. And then I want to be clear about what I'm putting in my data. So I'm going to use this parameter called columns, which lets me tell Pandas, hey, these are my column names. And I'm just going to call them A, B, and C. Cool. And now all I'm going to do is look at df1. And if I've typed correctly, yay, I have a data frame of which my rows are the inputted rows from the array, which are 1, 2, 3, 4, 5, 6, and 7, 8, 9. And my column are the labels I gave it, A, B, and C. Does this make sense intuitively to people? Are there any questions? Is Pandas working for people? No, I'm seeing some no's. If it's not working for you, please raise your hand and Charlie and Megan will come around and help. Yes.
So if you wanted to call for like a certain.
You can do that, and we will be getting to that super, super soon. But yeah, there is a way. The really nice thing about Pandas is I don't have to operate on an entire data frame. I can pick what data I want to use by rows and columns, which is super, super helpful. And that's kind of what you'll be doing most of the time anyways. Cool. So that's method 1. Method 2, like I said, we're going to create a data frame from scratch using a dictionary. Cool. All right. Let's create a dictionary. Does anybody remember? Oh, I just gave that away. Does anybody remember how we create a dictionary object? Like, what is the structure of a dictionary? Yes. Keys and values. Perfect. So you always have a key and a value. And what are those keys and values separated by? Perfect. And then how do you create a dictionary? Like just an empty dictionary? Yes. Perfect. So I'm going to do some curly brackets and I'm going to create a dictionary. My dictionary is going to, I don't know, I'm going to do fruits. Yes. Do you have a question? Oh, cool. You're good. So fruits is going to be my first key. And then I'm going to have a list of values. Can someone shout out 4 fruits altogether? Favorite fruits. Perfect. Strawberry. All right. Another one. Mango. Yay. Oh, that was really bad. I didn't mean to put that as a.
Oh.
No, they shouldn't need to. Weird. Okay. Don't worry about it. Then that's okay.
Oh, sometimes you have to like
Happens to-
from like stats models.
Oh, from stats model import API.
Yeah.
Okay.
you have to
Do you
I don't
want
know
to?
why.
Yeah. Okay, cool. If the stats model.api isn't working from you, you can try adding this line before you import stats models. You can say from stats models import API and then do the import. So if this isn't working for you, this is a potential fix. Okay, back to my dictionary. Two more fruits. Okay. Sleigh, apple. And then I'll go here. Cool. And let's say, I don't know. I'm clearly really bad at thinking of categories. Let's do colors. So I'm basically just making a dictionary of different things that I want to store in my data table, where each key is basically the string and each value is a list of a bunch of different values that correspond to that string. I don't know, planets. Cool. Oh, I should have done this. This will make things a lot more visible. Okay, cool. So now I have a dictionary of data that contains fruits, colors, and planets. And now I want to turn this into a cute little data frame like this. The way I'm going to do that, super similar to how we did it for the NumPy array. Sorry, for the NumPy array, we're going to do I'm going to call it df2 because it's my second data frame. I'm going to go pd.data frame and I'm going to call it on data dictionary. And I think you have to specify that that's the data. I'm not too sure if it works without that. We'll take a look. Let's actually try. Let's try. Let's try it together. Is it going to be a hater? It's not going to be a hater. Okay, yay. So now I have a cute little data frame with fruits, colors, and planets. Does this make sense? We just initialized an empty dictionary. You put in all your data into there, and then you can make it a nice little table. And so now what I want to draw your attention to is we didn't give it these numbers 0, 1, 2, 3. We didn't do that. So where are those numbers coming from? That is what a pandas index is. So remember how we were talking about when I was on the slides, pandas has this index data structure. That's what this is. So it's telling you that the 0th row contains strawberry red Mercury. The first row has mango blue Venus. Second row has apple cyan Jupiter, so on and so forth. This will be really helpful for when we want to go through rows and columns because you can just use those numbers. Does that make sense to people? Okay, cool. Now we're going to do the important part, the fun part, the part that we all are going to use. I hope that everyone has loaded in Titanic data.csv. Does everyone have that in their same directory as their notebook? If not, take a second to do that. But I am going to move forward with creating a data frame from existing data. The fun part. So it's really simple. It's great. So my data frame is data about the Titanic. So we're going to call it df Titanic. And all it is this cute little statement called pd.read CSV because it is a CSV file. And that's it. All you do is pd.read CSV of your file name. And I can now see a really nice data frame of a bunch of data about passengers on the Titanic. Does that make sense to people? So this was all obviously stored in that CSV Titanic data. And I'm now able to use it on Python as a pandas data frame. Super helpful, super useful. It's also like a really cute display, which is like so much better than like working with like multi-dimensional NumPy arrays where you have like just a bunch of rows and columns. This just makes it so much nicer. So this is what we are gonna hopefully work with from here on out. Yes. It doesn't show all the rows.
The point is to have a data frame to work with, right? Not to see your data.
Yeah, I mean, it does hold all the rows. You see these little dots?
Yeah.
Yeah, that's basically saying there are a bunch of other rows. You can force it to show those rows too. It's just like not showing them just so it doesn't take up a lot of space on your display.
Yeah, but the point is to just see the data. It's
Yeah.
be able to use it.
Yeah, so yes, it is able to, you're able to see your data, which is really helpful, but also super, super functional. Like we're gonna go in right now to looking at how we can access certain rows, access certain columns. And the really good thing about being able to work on a certain row or column is you can like do statistical, like you can use a bunch of NumPy functions on those rows and columns. You can find a max, you can find a min, you can find an average. You can also like delete rows and columns off your data frame. If you're like, this is useless information to me, you can get rid of it. You can also, there's a lot you can do. You can filter by certain rows and columns. You can, get rid of certain like values. Very, very helpful. Very good. Okay, cool. Beep, 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 beep. Let's hop back to my slides super, super quick. All right, so this is a recap. We just created a data frame in 3 different ways from scratch and using a CSV file and using a dictionary. Now we're gonna look at, like we said, how to select certain rows and columns. Cool. So selecting certain rows and columns, I call it slicing. There are 2 ways to do that in Pandas. The 2 methods are lock and iLock. .lock, it starts with an L, so it's label based. So it's based on the names of your columns or rows. And then .ilock is integer based. So it's based on the indexes of your rows and columns. I hope these little figures are like visible enough for you guys to see at the back. If not, the slides will be uploaded, so feel free to take a look. But basically, you can see if you do, in this little column, if you do df.lock Viper, it's going to give me the row Viper, which has the information of the max speed and a shield of a Viper. And also, the important thing to note is the way that Pandas goes by things is rows first and then columns, similar to how like NumPy does it. So anytime you specify something, make sure that you know whether you're looking for a row or a column. And if you want to do that thing where you select all the rows for a specific column, you use like a colon comma, very similar to like what we've been doing throughout this class so far. And I'll do an example so it becomes clear. But these are the 2 methods, lock and iLock. Oh, wait, hold up. That was gonna be part of my demo. Oopsies. I think it was yeah, that was gonna be part of my demo. That's on me. Okay, cool. For this demo, were people able to get statsmodel.api working? Is that still a problem for anyone? Question mark? Okay, cool. I just want to show you guys how to use different data sets from different sources, which is why I'm having you use statsmodel.api. We could totally just use this Titanic data. But I think it's fun to load in a bunch of data and mess with it. Cool. So now we're going to learn how to access rows and columns. Sorry, I am recovering from a terrible, terrible cough. Cool. So the way that you're going to use statsmodel.api, I don't really know how to do this. They did this in one of my classes and I've kind of been copying it ever since. So if you ask me about how this works, I might not be able to give you answers, but Google might. So the way that you access a data set, whatever data set that we want to access, literally is 96. I think this is what they named their data frame. So you just do sm.datasets. I'm basically assuming that this is a data set that exists in stats models and you're just bringing it into Python so you can start using it. I'm going to print 96.note. The .note is basically like just like information about this data set. Cool. So by looking at this information, you see that there's 944 rows, 10 columns, so 10 variables. And these are all the variables. So clearly it is some kind of data set about political things. We see like party, we see people expected to vote for a certain individual and then their kind of like political position. Yeah, cool. So that's this data set. There's also some other information about like your age, your education, yada, yada, yada. So that's what this data set is. Oof, sorry, my cough. Cool. And then to save this as a data frame, because right now this isn't a pandas data frame, all we're gonna do is
Everyone in the back seat.
oh, I should, okay. Cool. Again, this is, I guess, how the SM model works. I am so sorry that I cannot give you more details on that, but if you want to load in any data from the stats models, this is the same process to do that. That I will give you clarity on, yes.
The above part you used print, but you weren't using it before. Why?
Oh, that was just me being silly and not using print anywhere. You could totally use print.
It does the exact thing.
It should do the exact same thing. I just kind of get lazy. Oh, okay. Apparently print doesn't actually, oh, I actually did not know this. When you print a data frame, it doesn't render as an actual cute little data frame. Okay, cool. I kind of usually just, I'm really bad at like coding and all of my things in the same cell. I do a bunch of things in like different cells. I like very much segment my code, which is like, some people will be haters for that. And you know what? That's fine. I just really like breaking down my code into like literally the tiniest possible segments. Like I put 2 lines in a cell. So what I'm able to do basically is df2, because this is like my last call to the data frame. Like I'm not doing anything past that point. So it's able to just like display that last result. But like, for example, if I were to do like another line of code here, like if I were to, I don't know, I can't think of a line of code, like do x equals 3 plus 2 or something. And then if I were to do the df2 call here, it wouldn't show me that because it's not the last thing that's being executed by Python. So then I would have to do display df2, and then it'll do that for me. Before, that will also work.
Oh.
Yeah. Okay, so for pandas data frames, good to know, don't use print, use display. Thank you. Very, very good question. Cool. Back to loading this in. Okay, and so then I'm going to, this is now the part I'm familiar with, which is now we're making it a pandas data frame, which is, I'm going to call it elections data frame because it's data frame about a presidential election. You're going to do data set -96.data. So all these little commands are part of the like SM model. So again, unfortunately, not super familiar, but if there are specific questions, I will look into the documentation and give you guys answers. Probably just like not on the spot right now because I don't know things. But yay, I have now created a nice little pandas data frame, 944 rows, 11 columns that contains all this election data. Cool. Can I get like just a general thumbs up if this worked for people? Yay, exciting. Okay, good. So now we also have learned about another cool package that lets you import a bunch of data. I haven't really looked into stats models a lot, but you definitely can find their documentation online. And if anyone wants to like use it to find interesting data to use for your final projects, go for it. Totally open to doing that. You can also totally find, I know Seaborn has a bunch of data that exists on there that you can use. They have a really cute data set about penguins that I've used quite a few times. You can surprisingly find a lot of packages on Python that have data inbuilt into them. So if you're ever like, hey, I want to maybe look for some, yeah, you can always look through certain documentation of packages like stats models or of packages like Seaborn to see what data they hold. Totally good to use that data too. You can use any data. You just might have to load it in a little differently because it's not like loading in a CSV file. You'll have to do it this way according to whatever the package instructions are. Cool. Now let's move into lock and iLock. So lock, as I said, is label-based indexing. So what might be a little confusing here? Just a tiny bit. The rows don't really have labels. Their labels are these little indexes. So their labels are numbers, which is kind of confusing. Because you in your head are probably like, that's not a word, like that's not a string, that's not a label. But you don't usually label your rows, because usually rows are just like row 0, row 1, yada, yada, yada. You could do it, but in most data, you're not going to really see a row label. You usually have column labels. Those obviously exist. But let's say I want to get the 4th row of this data frame. I'm going to do elections df.lock, and I'm literally going to put in the number 4. And that has given me, just for a sanity check, apparently populate, or I don't know what this stands for, but popularity, maybe something? I did not look this up. Oh, census place. Okay, so it's like the population, a census count should be 640. I got 640. TV news should be 7. So it's basically outputting that specific row. And this data structure is called a Pandas series. Like I was talking about earlier in our lecture, if you have a specific row or column, this is a Pandas series object. And you can see that everything in this series has the data type of a float. Super useful. So you can see that this is called row 4 because, again, as I said, rows don't have labels. Now, let's say I want to get a column. Dot lock. Does anyone want to like give me a guess as to how I can get, let's say I want PID. And you want to get it by the label. I don't want you to get it by the index. Or yes. Yep, so you can do the colon comma to get all the rows in a given column. And then I wanted the column PID. So I'm gonna get the column PID. Yay! Now I have this column with the name PID. It's gonna have the 944 data points and they're all floats because all the PIDs are these numbers. And you can do the same for like age. Oh, that's not what I meant to change there. Oops. Well, my Python's gonna hate on me for that for a little bit. But you could do the same thing for age, any of the columns in the data frame. So that is .lock. And then .ilock, like I said, is index-based. So ilock will take this as column 0, this is column 1, this is column 2, so on and so forth. And then because the rows don't have labels, they just have these numbers, it's going to do the same thing. This is row 0, this is row 1, so on and so forth. So it's based on the numbers. Cool. So now we're going to use ilock. And with ilock, I'm not going to show you how it works for just like one specific row or column because I feel like that one's that's pretty intuitive, hopefully. If there's any questions, feel free to let me know. But one really, really helpful thing is you can specify like a range of rows or a range of columns that you want to look at, which is always super, super nice. So I'm going to do elections df.ilock 3 to 6. So does anyone have a guess as to what this is given me? What is my result? Yes. But say that, yes, but not including 6. Perfect. So what I've basically been able to do is select rows 3 to 6 using this little slice. And then I haven't specified anything for the columns, so it's giving me all the columns. And it's not including 6. So same as we always do with indexing. Now let's say I want rows 3 to 6, but only for the first 2 columns, or the first, let's say I want from popul to self LR. Does anyone want to tell me what I can do to get that? Yes. I think it's 0 to 3. I could be silly. Yeah, so 0 to 3 because yes. That's a good question. You can basically also do this with .lock. So the one thing is you have to be consistent. So .lock, it'll work, but I now need to call it on the specific, I think you could do this. Let's test it together. So you could do it with the label names. Cool. And again, I'm reminding you, this only works. I kept this the same because there are no row names. Does that make sense? Okay, cool. So that is how dot lock works. Oh, interesting. Is dot lock inclusive?
What are the data types of these objects?
Of which objects?
Like the dot lock and the dot.
These little results, so these are all data frames. They're just tinier data frames. But when you're selecting just a singular row or column, that's a series. So a bunch of series make up a data frame. Cool. But yeah, so these are all just like little baby data frames, sub data frames of your original. Interesting. I think dot lock is inclusive while dot ilock isn't. Don't hold me to it, but I feel like that's what's happening, which I think is cool.
iLock is integer specific. It's like
Mhm.
integer locate. There's a reason and it works better for certain situations. I can't remember what they are.
Yeah.
Yeah, I tried with I love and it didn't work.
So you can't use names for ilock.
Oh,
ilock is only numbers because it's integer based. It's index based. So dot lock here works because I'm using labels. But if I want to do the same, get the same data frame using dot ilock, you would actually have to go 3 to 7, is what I'm now discovering, and 0 through 2. Oh, I'm silly. Sorry, my Python's going to be a hater again for that, but hopefully this runs and it will work once it runs. Cool. So that is how you do index-based and label-based indexing. Super helpful, as we know. Exciting things. Cool. The one last thing I want to show you, there's also, you can use, oh my God. Cool. Oh, I could have shown you guys that error. That's silly of me. That error was basically telling me there was a type error because I was trying to use dot lock with numbers. Because it's like, what are these column numbers? I don't know what these are. So you can always read the little type errors to help you know what's going on. Cool. So this is how you get the same kind of data frame using lock and ilock. Interesting. One is inclusive, one is exclusive. I didn't know that. But I guess it makes sense. One other thing you can do, sometimes you just want to like quickly access a specific column, or if you want to add a new column to a data frame or something like that, you want to just access a column. You can also do that by literally just calling the name of the column. So it kind of does the same thing as lock and ilock. This is not going to work for rows. It's only going to work for the columns. But if I did like elections df at 0, it should error out and be like, I don't know what column 0 is. But I hope that makes sense. You're just calling the name of the column. So sometimes like you want to like access just a specific column. You don't want to use lock. You don't want to use ilock. You can just call the column name if you're just doing it with one column. You can also, I think, do this with like a list of column names, but you please don't hold me to that. Yeah, so now it's giving me a key error because it has no idea what column 0 is. But if I give it like PID, it's going to just throw out the column. Okay, cool. So that was like a super, super basic outline of all the fun indexing things you can do with pandas. Cool. Are there any questions? Are there any?
When it comes to like accessing this data to like plot it,
Mhm.
how would you go about it?
Very, very good question. So when you want to plot, usually all your plots taken in an X and a Y, and usually we've been giving them array. NumPy works with Pandas series as well. So, I mean, we have like 2 minutes. If people want to linger around and see how to plot something super quick, I can totally do that. Like, let's say I want to make a scatter plot of like, I don't know, age and education. That's probably not going to give me anything relevant. So let's say I want age on my x-axis. I can do elections df at age. And I'm going to put my y elections df at, I don't know, I'll use PID. Before that, I should import matplotlib. And then, same way that we've always been doing, we can do a PLT dot figure, PLT dot scatter, X and Y, PLT dot show. So you can make a super quick plot. I don't think this plot is going to show me anything relevant or useful, but that's how you can plot. So you can just treat any row or any column as, yeah, okay, so this is clearly a terrible plot because I didn't look at the data and I have no idea what's going on because clearly these are all integers. So maybe making a bar chart would be more useful in some situation like this. But that's how you do a plot. You just define an X, define a Y, and go for it. You can also kind of directly put these in here. You could totally do this as well. I just sometimes like having variables for like ease of my mind. Because I'm like, I definitely know what X and Y are because I wrote that they're these things. Also, sometimes like these, if you're like using dot lock and dot ilock and like going through a large range, they'll become kind of long, nasty expressions. So you might want to separate it out. But that's how you do a plot. Very good question. Any other questions? I know time is up, but we will linger and answer anything if you guys have any. And feel free to come into office hours.
We will not linger very long because there is a class right after us.
We will linger very briefly.